So up to now we've looked at how to plot graphs and how to plot a single graph on the screen, which is useful for us to quickly get a graph, copy it, paste it into a report, and then discuss in the report. But often we want to look at plotting different graphs on the same sort of page, and in the same way we'll be able to then sort of go in between the graphs and relate between them and discuss and see in details, and you can also see at the different points where one might be peaking, the other one might be dipping, and so it's sometimes useful to be able to see a group of graphs placed next to each other to be able to do this analysis. And this is what's known as subplots, and that's what we're going to be looking at in this specific video. So subplots is going to in this specific sort of session, what we're going to be doing is we're going to have three different plots that we're going to be looking at, one below each other, and in this way we'll be able to then sort of see how one function might differ to another function, or one sort of graph shape might differ from another one. And so it will be quite useful for reports and those kind of things to occur. Right, so again, I've got my standard format for the program over here. Again, we looking at standard input output, the standard library, the math, and the chplot libraries being declared over there. Okay, so what I'm going to do over here is, before I get to the main program, I'm going to have three different functions I'm going to create, and these functions are going to be correlating with each graph that I'm going to be plotting. Okay, so double func1 will be my function 1, which will be double x, and this will be return, and I'm going to have the expression 2 multiplied by t multiplied by t multiplied by t, so that's 2t cubed essentially, minus 24 multiplied by t plus 6. So essentially this expression is 2t cubed plus minus 24t plus 6. Okay, so that's the expression we're going to have for this func1. And now we're going to be looking at double func2. That's also going to be a double x. Now something to keep in mind is that this x obviously for this function is not the same as this x in this function. These values of x get sort of cleared as soon as we exit these functions and the value gets returned back into the main program. Okay, so for function 2, I'm going to have returning 6 multiplied by t squared minus 24. Okay, and then I'm going to have another function, func3, which will be also a double over there, and a double t. Actually, so I've made an error over here, so I've got a double x over there in the bracket. Those x's should be t's, because that's the variable that gets used within each function. Okay, and over here we've got for this one we're returning 12 multiplied by t. Okay, so we've got our three functions, so we're going to be comparing in a specific example. Func1, func2 and func3 need to be together as a single word. Okay, now we get into our main program. So again, in our main program, we're going to have subplot plot, well, the difference where we're going to have, where we normally would have cplot plot, now we're going to have cplot subplot. Okay, and after subplot we're going to have comma, a star, and a plot. Okay, so this is a standard statement that we start all our code. We declare in the variable, this is variable over here, and it's going to be sort of related within the code. Okay, so it's a little bit of a difference to your normal plots that you would have had. So this is sort of an addition with a subplot. Okay, after we've done this, we need to indicate to the computer when it starts plotting these graphs out, how many graphs must be laid out. Okay, so, I mean, do we want 2 graphs, 3 graphs? Do we want, how many do we want? Okay, so the command for that is subplot.plot 3,1. So in this case, I've actually indicated that I've got 3 rows, in other words 3 graphs underneath each other by 1 column. So it will be having 3 graphs underneath each other. It would be interesting for you to do as an exercise to change these values and see if you get more plots able to do. Maybe you're able to have 3, 2 to have 2 plots on each row, and how it would influence the viewing of the screen. Okay, so once we've done that, we need to now sort of indicate, obviously, each graph that we're going to be plotting, whether we're looking at the x-axis that we're going to be naming or so. Every time we're going to do that, the same command is essentially going to be used for each plot, and we need to differentiate between which graph are we looking at that specific time. Okay, so there's a command that we're going to use, which is plot is equal to subplot dot get subplot (0, 0). Okay, so basically this is the first graph that we're looking at in position 0, 0. Again, it's like an array, so you starting count from position 0. So this is the reason why we're doing it. And this is essentially like a heading that we're given, and we're looking at the first graph. Okay, so we're going to now indicate what the x and y axis is for these different graphs, and the instructions are a little bit different to what we've seen in the past. So we will have plot, and then it will be a dash and a greater than sign to create like an arrow, and then we have the command label open bracket plot axis or axis x, and that would be whatever our x-axis label would be. Okay, so as you can see, the syntax is very much the same as you would have with the plot.label type of commands, but we've got this arrow that's in between. Okay, again, the same type of approach will be used where we've got for the y-axis, so plot axis y, comma, and our y-axis label. Okay, then another thing, just keep in mind, have a look at where uppercases are in the commands, because that does influence your statement, as we've seen before. Okay, so for our first plot that we're going to be doing, we're going to be plotting a 2D function, so therefore func 2D, and that's going to be 0, 10, 100, okay, func1. Okay, so essentially we're going to go from 0 to 10 on of the x values that we're going to be looking at. So initial x value is 0, final x value is 10. There's going to be 100 points in between there, and we're going to be calling up function 1. Okay, so this is all going to be happening for this specific graph. We've now indicated what the x and y labels are. We've indicated what the function for it is. Let's do ourselves a quick favor and just see what happens if we run the program. Okay, well, it says over there error. There needs to be a semicolon after that return statement. Let's try again. Okay, plot.plotting. It's not liking that. It's saying that. Ooh, what's the reason for that not to work? I need to have over here subplot.plotting, not just plot.plotting. So it's again a very small change that we need to keep into account. So as you can see with this plot that has been generated, there's been enough space that's been placed below each other for 3 of these graphs to be made. Okay, and we can see that the first graph has been placed there. We've got our y-axis label that's been placed over there. We've got our x-axis label placed over there. We've got the graph that is plotted over there. So it seems like our structure is and the way that we are doing this is correct. These have been the commands that we've typed out that gave us that single plot. Now essentially the same commands are going to be needed for the other 2 plots with slight differences. So what I'm going to be doing is I'm going to copy these 4 lines. And I'm going to be pasting them below it. So the first one will be over here, and the next one would be over here. Okay, so we've got a set of commands or a group of commands that is for each specific graph that we're going to have underneath each other. Okay, now what we've got to do is we've got to differentiate between this graph and this one, and that's where this plot equals to subplots.getSubplot needs to change. So we need to go and change that first 0 to 1 and this first 0 of the second group to 2. So that indicates to us it's graph number 0, graph number 1, graph number 2. And all the commands under each of these specific headings will be associated to that graph. So these 3 commands over here, they are going to be associated with graph 0, or our first graph that we will see. These 3 lines over here of code will be associated with graph number 1, or our second graph that will appear. And then these 3 commands over here will be associated with graph number 2, or the third graph that we will then see. Okay, the other thing that we just need to change over here is, I mean, obviously you can change your x-axis label and y-axis label. Well, just make it maybe x2 and y2 axis. Well, for the sake of just to see that there is differentiation between the different axes and names. Okay, so we've done that, and then what we're also going to be doing is we're going to be changing the functions for each one. So this will be function 2, and the third graph will actually have function 3 being executed over there. Okay, so let's see what happens when we run this program. This is the output that we get now from those 3 sets of code. As you can see, we've got over here y-axis label, y2 axis label, and y3 axis label. we've got x-axis label over there, x2 axis label, and x3 axis label over there. So each graph has been given its axis labels accordingly as we wanted it to be. And you will see that each specific graph has got a specific function that it is plotting. So each graph is slightly different over here if you have to compare them. Okay, so obviously you can go and change those functions. You can make it any other type of functions you might want. You might have assignments, or you might have projects that you are doing, and there's different functions you want to compare to make sure, or to see, how they might differ, or what the difference in results might be for different values of those variables. So you can actually do it over here, and then with a quick glance be able to see how they compare. And again, you can copy this whole block as one image and then paste it into your assignment or reports. You'd have noticed that there is very much similar sort of structures in terms of the command names, in terms of what you want to do in between plots and subplots, with slight differences. So let's quickly go over them just to recap in terms of what have been the critical changes that we have to take into account. So again, we had, for this example, 3 different graphs. So we had 3 different functions that we kept in mind. And again, like I mentioned before, change these functions, make it to something that might be of value to you to be used for assignments and projects. Okay, the first change we have to take into account is this cplot, subplot, star plot. So that's the first major change that we saw. Then we've got subplot.plot 3,1. That's indicating to us how many graphs we're going to have. So how many graphs need to be made available on the screen. And in this case, it's 3 rows by 1 column. Then we're going to have a command which will be plot is equal to subplot dot get subplot, and then 2 numbers. Now these 2 numbers are correlating with the x and the y position on the page that you've got for your graphs to indicate where this specific plot needs to be placed. So in this case, it's our first graph that we're looking at on the page. We give it specific labels for that first graph, and we give it a specific function. Then we have again this plot is equal to subplot, get subplot, and we look at the next graph, which is 1, 0. So all the commands below that will follow will be for specifically for the subplot number 1, or in our case it would appear as the second figure. Okay, and similarly the same sort of scenario would be for the third plot. Okay, let's just have a look again what it is in terms of how we've got to type the commands. Again, there's a slight difference with the subplots. Instead of having a plot.label or plot.func2d or similar type of command, you've got plot space, a dash, and a greater than sign to create like an arrow, and then label, and then whatever the label is over there. Or in other words, it could also be plot, an arrow, and func2d, and in the different variables and values that you've got to have there for the different terms within the function. Okay, so the same thing applies for each graph or each subplot within that graph that we had to look at. And then again, ending up with plot.plotting, we're not going to use that anymore when it comes to subplots. It becomes a subplot.plotting. And again, the 2 brackets over there are critical to have. And then we end it off with the return 0. Okay, so I hope with this you are able to then do these subplots, and it would be valuable to you for other courses. Right, so basically that wraps up in terms of graphs. If we look at what we've covered in these videos, in at least the series so far, we've looked at all different type of commands. We've looked at how we can do use these different commands to solve problems. We've looked at the basic commands. Like I said, this is your basic toolbox. You need to be able to use those tools that's made available. It's almost like a MacGyver situation. You can't go and sort of say, oh, I'm quickly going to take out a saw. You might not have a saw available. You've got only these tools available, and you've got to solve this problem using the tools that we've gone through and that is made available to you. So the questions that you would often have in tests and exams would be ones that will take into account that you must be able to solve them with the tools or the commands that we've covered so far. It is also maybe a little bit of a guidance to you, because when you see a problem, you will know that there's a specific way to approach it, because we are sort of restricted in terms of how much we can expect you to do with a specific example. And then we looked at graphs, how to plot them, how to label them, and inserted silly, or not silly, but the special features into them. Things like the legends and where they will be located. We looked at how to plot different types of graphs, whether it is surface graphs or whether it is 2D curves, 3D curves. We looked at how we're able to plot data plots, and now again subplots. So with all these tools, it would and hopefully will be able to assist you later on in other courses and assignments, as well as later on in your job, to be able to do these type of plots and to then use them in your analysis.